Hello friends, my name is Yuri Kovalyanok and I like to take notes. Today I decided to analyze with you the solution of one of the problems, the solution of which is published in my Instagram, Facebook and Twitter. This is a combined task. Imagine that you have a mathematical pendulum that is placed between the plates of a flat capacitor. A pendulum of mass m is suspended on a thread of lane shell and has a charge q and is located in an electrical field between the plates of a flat capacitor with a voltage of A. You need to find the period of oscillation of this pendulum. In order to solve this problem, you need to imagine a simple mathematical pendulum that oscillates only under the influence of gravity. In this case, the letter T indicates the tension force of the thread. The resulting gravity and tension forces of the thread are directed to the position of stable equilibrium. In this case, the oscillation period is determined by the formula known to you. As you can see, the oscillation period is determined by the length of the pendulum and the acceleration of free fall. What happens to the oscillation period if the pendulum is lowered between the capacitor plates? Let's write down the forces that act on the pendulum. So we have the thread tension force, the gravity force and the Coulomb force. If you add up all these forces, then the resulting force should be directed to a position of stable equilibrium. And in this case, instead of the acceleration of free fall, we need to use the acceleration with a stroke. Acceleration with a stroke creates the force of gravity with a stroke, which can be found by the Pythagorean theorem. And in the end, we get this result. We can transfer the mass to the denominator, and then we can obviously fairly say that the oscillation period will decrease. That's all, my friends, for now. Many of my notes can be purchased from the link that I will leave in the description of this video. If you have any suggestions, then write about in the comments. I will be glad if you subscribe to my channel. All bye, sincerely, Yuri Kovalyanok.